Coir fibre is a natural fibre obtained from the husk of coconuts. It is used for a wide range of applications, including the production of mats, rugs, brushes, and twine. Coir fibre is strong, flexible, and durable, making it an ideal material for various products. It is also naturally resistant to moisture, pests, and decay, which makes it a popular choice for outdoor use. Additionally, coir fibre is environmentally friendly, as it is a renewable resource that is biodegradable at the end of its life cycle.
Use of fly ash in cement for concrete structures. Roller compacted concrete pavement. Cold mix technology using bitumen emulsions for bituminous wearing coat. Use of waste plastic in bituminous works. Use of blast furnace slag. Cell-filled concrete technology. And the last, but certainly not the least, is the use of Coir geotextiles in rural roads construction, a technology that stands out on account of its ecological compatibility and cost effectiveness. Slowly but surely, this path-breaking innovation is transforming the present and beckoning the future. A future of eco-friendly roads. Layer between the aggregate and the subgrade soil to prevent migration of fines and thus preserve the structural thickness of the aggregate by maintaining it clean. Coir geotextiles are recommended for this function because of the low cost, high coefficient of friction, high elongation 30% and high coefficient of permeability, besides good drape to conform to the contour of the surface. See how this technology is put to practical use. To begin with, the subgrade is prepared to the required compaction and camber. This initial stage is extremely important, holding the key to the desired end result.
After putting the optimum moisture and rolling to the 100% compaction, we have to check it again for whether it is being compacted to the 100%. So for that, the tests available is a sand replacement method either or core cutter method. So here what we done is a sand replacement method. So in that we will be digging a hole of a 10 centimeter dia and 10 centimeter depth, and whatever the soil we have taken inside from that hole, that will be taking the weight, and also we will be checking the moisture content of the soil, and we will be placing the sand pouring cylinder above that, and sand is poured into the hole, and again the volume what we are finding out the hole for checking the weight of the soil and the volume comparison to find out the density of the soil what we dug. So that density will be compared with the original density, that is the maximum dry density we have tested from the lab. Then we will compare it, whether it is coming to the near or above, then that is good. Other, if it is coming below, that is poor compaction or less than 100%. So once again we have to apply the watering, that is to be made the optimum moisture. Again we have to re-roll. So whatever we tested is exactly 100%. So we are getting a good compaction over here, and it is ready for the subsequent layers. That is, we are going to place the geotextile above that.
Clearing the subgrade is followed by rolling out the first roll of Coir geotextile using one of the edges as reference. The second and third rolls are rolled out in the next stage, maintaining the required overlap. Special attention is paid to ensuring the removal of folds and wrinkles. The rolls are then fixed to the subgrade by using clamps after folding for a small length at the beginning and end of the roll. And also at the curves and slopes in order to avoid chances of movement. The geotextile needs to be folded properly, not for full width, to account for the difference in length along the two edges, inner and outer, of the road curves. Thereafter, each roll is tied at the overlaps using cable ties in the spacing of not less than 1 meter. The next stage is about the preparation of the sub-base. For this, the lorry tipper is brought to the tip of the geotextile and the material dumped over it. It can also be done manually. Any movement of construction equipment directly on the geotextile is to be very carefully and consciously avoided. The dumped material is then evenly spread either manually or mechanically by using the JCB to the designed thickness. Then the profiles are corrected manually for the required camber and super elevation. A roller is then used to roll the material to 100% compaction. After finishing the GSB layer, the shoulders are maintained with good gravel earth for spreading the grade 2 material as base layer, the width of which is 3.8 meters. This is dry rolled to the required compaction and the screening material is applied to fill in the pores. Water is sprinkled over and it is then re-rolled. The next stage is spreading the binder earth on the surface, which is water rolled as per specifications. With this process over, it is allowed to cure or dry for a few days before the commencement of next stage. The grade 3 layer is then spread in the same manner as grade 2. And the screening material is again applied to fill in the pores. But at this stage, instead of binder earth, slow-setting bitumen emulsion is applied as prime coat for bonding. Above this base layer, rapid-setting bitumen emulsion is applied as tack coat, followed by 20 mm thick premixed shipping carpet using natural rubber modified bitumen or NRMB or VG30 grade bitumen. Finally, a seat coat using the same bitumen is spread over to finalize the surface. The results of the multiple advantages of this path-breaking technology are there for everyone to see. Out of the many roads constructed using this useful and innovative technology, needless to say, this cost-competitive, eco-friendly solution is here to stay.
Thanks for watching. Please like, comment, share and subscribe. Support us new YouTuber for more new technology and innovations.